Okay, awesome. So, first off, welcome everyone to the Ethereum merge party with TPG. We are super excited to host this primarily because the merge itself is one of the biggest events that have happened in the crypto ecosystem so far. We keep seeing a lot of news about like trading, about tokens going up and down, markets crashing, and things like that, but really the merge is one of the technical events that has changed, that will change the way people look at how blockchain functions. And big why this event is a huge event, let me tell you. It's because this event is performing operations on a blockchain network, on a piece of technology that multiple people across the globe are working on, right? So you have node operators who actually run the Ethereum nodes across the globe. So this is truly an entire community, a global community coming together and making the change from one type of blockchain to another type of blockchain. That's why this is so important. There have been such less events in the history of the world where people across the globe have come together to do something, to contribute to something, right? And it is very significant personally for me because right now you see so much conflicts happening between borders, but you see technology is one of the things that can bring everyone together. So that's why the merge is like super interesting, super exciting as well. And I am happy to share this event with all of you. The agenda is very simple. We have a small introduction, TPG. Most of you are already familiar with what we do, so I'm going to run through that very fast. Understanding the merge. So I'm not going to. I don't have too many slides. Instead, I have a really amazing video from Finematics that explains the various components of the merge. I want to give some space for open conversations to discuss what you think about the merge, like, what are your questions, and maybe let us try to find out some answers together. There is a fun quiz that I put up. It's a very short quiz, but it's just a fun way to sort of do something and get some quick bounties. What next is actually just after understanding the merge itself, so I've moved that order. About the Phoenix Guild, we are a community that is created to help onboard the next million female and non-binary builders. We are passionate about having more underrepresented folks in the Web3 ecosystem, and that's how we started this community. We are focused on education. We are focused on the pipeline where we can help you get opportunities, as well as help close the loop by recommending you for jobs, recommending you for VC funding, grant funding, etc. Our long term vision is to have more women and non binary folks represented at leadership positions like CXOs, entrepreneurs in the Web3 space. This is the core team of the Phoenix Guild. We have Nivedita, who's on the call, myself, Gyan Lakshmi, Sri Lakshmi, and Sneha. So four of us work together in terms of bringing you whatever the opportunities we can. All right. So just to show you like a brief idea of what the merge is, the merge is the Ethereum blockchain network moving from proof of work to proof of stake. How did this process happen? This process did not actually just start. This process started a while ago when Ethereum was running proof of work. The main chain was running on proof of work. Parallelly, there was another chain that was copying all the transactions that are happening on proof of work, and there was a new chain spun out called the beacon chain, right? And now this beacon chain started producing blocks at the end of 2020 December. That's when the beacon chain produced the first block, and then onwards there an entire year, almost a year and a half, people have been waiting in anticipation for the existing proof of work chain to also completely migrate to proof of stake. The main idea behind this merge is to make sure that Ethereum is a more environment friendly blockchain. That's the idea from which the entire merge concept has actually emerged. There are a lot of technical implications that make Ethereum a better chain. after the merge than as compared to before the merge. But the biggest idea is to make it greener, right? That's the idea with which the merge actually happened. So you can see this diagram that when proof of work was already there, when chain was already in proof of work, the beacon chain had already started, right? I wonder why there were not beacon chain parties happening before, but we all celebrated some way or the other. So this is the main event itself that happened. Now, this is not, however, this is not the only thing that is happening for Ethereum as an upgrade, right? There are going to be various phases of what now they stopped calling it 2.0, but kind of 2.0, right? For Ethereum, what is next for Ethereum? The first is the merge. We are already done with that. The next is something called the surge, where they are going to introduce the concept of sharding. The entire network will be split into smaller shards, and it will be, computation will become much scalable. Then the next two, the verge and the purge, are related to data storage upgrades. So right now, the data that is stored on Ethereum is stored in the form of in a tree structure, where you have the root, which gives you the final hash, and then the smaller data is stored like in the form of steps. So you don't have to necessarily know about this, but if you are interested in Merkle trees, that's the existing data structure. I will share more links. I'll share a lot of reading links around this. So whichever one you feel like exploring, you can just go deep into that. So right now it is called the Merkle trees, but Merkle trees are going to get an upgrade to something called the Verkle trees, and that will improve the way the transactions are stored in the entire blockchain as well. The purge is a similar upgrade which will work on data storage for validators. So if you have a question in terms of like what are validators and what does this term mean, right now in proof of work we have something called miners who are performing extremely hard mathematical calculation, right? Imagine when Ethereum started, they were doing this on their laptop, that they were trying to solve a puzzle, right? And trying to generate some random numbers, so that they are able to generate a random number that matches the final answer. And to do that they had to keep running some algorithms, right? This was what miners were doing. But in proof of stake, there is another mechanism called where we have validators. Validators are going to be the one that are going to stake some Ethereum onto the network, right? That's why it's proof of stake. And based on how much who has staked, they will be able to produce the next set of blocks. So this proof of stake versus proof of work is for producing the next set of blocks, right? Now, this purge is an upgrade that is for validators, data storage for validators, because validators keep producing new blocks. So they will have to run the entire node, right? Most times. So how can they optimize on space and storage? Now, the last one is called the splurge, as the name suggests. We are going to splurge on additional features and updates that will help make the chain more stable after all of these phases. So, right now, the one phase that we have completed is the merge. What next? We have the surge, the verge. The surge is sharding is aimed for 2023, mid 2023, next year. And then we have the other upgrades coming on the go. So to understand this better, I actually want to play this video, and I'm going to also share the link with you all. You would be interested in watching. Let me. So there are two things that I'm going to play. One is going to be what is Ethereum 2.0. So this explains all the concepts really nicely, and that's why I wanted us to watch this. And then we'll watch a little bit of what actually transpired during the merge, right? What everyone was watching, what were they doing, what were the things that they were looking for, which indicates that the merge has happened. We will watch that as well. Right. All right. So I'm going to play this. And if you have any questions, After this, we'll take like a 5 minute sort of, 5-10 minute. We'll just open it up for conversations. And if you, meanwhile, if you can think of any questions, keep putting it up on the chat, and we'll bring it up during our 5 minute sort of time box. All right.
2.0 all about? What is proof of?
Sorry.
So what is the long-awaited Ethereum 2.0 all about? What is proof of stake, the beacon chain, sharding, and docking? And what are the different phases of the rollouts? You'll find answers to these questions in this video. Before we begin, if you want to learn more about decentralized finance and the technology behind it, make sure you subscribe to my channel, hit the bell icon, and enable all notifications. You can also consider supporting us on Patreon and joining our community of DeFi enthusiasts. Let's start with an overview of what Ethereum 2.0 is and why it's even needed in the first place. Ethereum 2.0, aka ETH2, is a set of interconnected upgrades to the Ethereum network that aims at making Ethereum more scalable, more secure, and more sustainable. These changes are worked on by multiple different teams in the Ethereum ecosystem, each team focusing on building a specific part of the whole upgrade. Now, let's quickly go through all of the main goals of ETH2. Scalability. The current Ethereum network supports around 15 transactions per second. This becomes a limiting factor when it comes to onboarding millions of new users and launching many more decentralized applications. To make Ethereum more scalable, ETH2 aims at supporting thousands of transactions per second. One important caveat: the increase in transactions per second should not come at a cost of increasing the size of the nodes in the network. Security. Security of a decentralized network is always one of the top priorities. ETH2 aims at increasing the security of the network against all forms of attack, including a 51% attack, where someone can force through fraudulent changes by controlling the majority of the network. Sustainability. The well-known proof-of-work-based consensus model used by the current Ethereum network requires a lot of computing power and energy. ETH2 aims at making Ethereum better for the environment by replacing energy-intensive proof-of-work with proof-of-stake. Initially, the set of changes needed to achieve these goals was called Serenity, but now most people refer to it as Ethereum 2.0 or just ETH2. What is interesting is that all of these goals were pretty much always in the Ethereum roadmap, and they had been discussed even before the network officially launched. Let's start with one of the biggest changes, the consensus model shift from proof of work to proof of stake. The current Ethereum consensus model, proof of work, is a well-known and battle-tested approach to building cryptocurrencies. In proof of work, miners invest their resources, mainly electricity, to validate transactions and secure the network. This model requires massive amounts of energy to work properly and protect the network from 51% attacks. Proof of stake tries to address the power consumption concerns by getting rid of the miners completely. Instead of machines securing the network by investing their resources, the proof of stake consensus model relies on economic incentives. In proof of stake, users who want to secure the network stake their ETH and become validators. Each validator is incentivized to validate transactions by receiving, similarly to miners in proof of work, both the block reward and the transaction fees. To discourage validators from trying to game the system and validate fraudulent transactions, the proof of stake system implements a mechanism called slashing, where validators lose part of their staked ETH if they decide to act dishonestly. In order to pull off a successful 51% attack in a proof of stake system, the attacker would have to control 51% of the validators, which would require owning 50.
Oops, sorry. Looks like my internet is glitchy. Just give me one moment. I think I have a lot of tabs that I'm just
1% of all staked ETH, a massive amount of capital. So, in order to become one of the ETH2 validators, 32 ETH is required. It is also possible to stake with less than 32 ETH by using staking pools, for example, Rocket Pool. The returns for validators depend on the amount of staked ETH in the system. They can be as high as over 18% annually if there is less than 1 million ETH staked, and as low as 1.81% or even lower if there is more than 100 million ETH in the system. Proof of stake addresses all three of the ETH2 goals. It makes Ethereum
I'm not able to see the screen.
energy intensive market.
Oh, you're not able to see this.
Yeah, even me, it's on now.
Maybe because of screen sharing, it was like, yeah. Is it
Yeah,
seen?
it's fine now.
Okay.
Yeah, I can see.
It makes it more secure by making a 51% attack harder, and it makes it more scalable by unlocking sharding that would be much harder to achieve in a proof of work model, as it would most likely result in diluting the amount of computing power across multiple shards. This is actually a good segue into sharding. The concept of sharding is not specific to the ETH2 upgrade. It's actually a common process in computer science that allows for splitting a database into multiple instances, each containing a portion of the whole dataset. Each instance would be known as a shard. When it comes to ETH2, each shard is basically a separate new chain. Initially, there will be 64 of them. This directly addresses Ethereum's scalability concerns, as shards will allow for spreading the network's load. On top of that, each Ethereum node will only have to run one of the shards. This means storing only a small subset of data and making it easier to run a node without having powerful hardware. Making nodes easier to run should result in more network participants, which equals more decentralization and more security. Initially, sharding will just provide extra data. Sharded chains won't be able to handle transactions or smart contracts. At this point, you're probably asking the question, so how can sharding improve scalability without handling transactions or smart contracts? Improving scalability will be possible because of layer 2 scaling, in particular, rollups. Rollups allow for bundling transactions off-chain, generating a cryptographic proof and submitting it to the chain. This process only requires a data shard to be available to store the proof, which means it can be used with the initial version of sharding. You can learn more about layer 2 scaling and rollups here. This is not the end, although the mix of data sharding and rollups should result in Ethereum being able to process over 100,000 transactions per second. There is also another improvement that can be made. There is a possibility to upgrade shards to make them fully executable in the same way as the current Ethereum chain. It remains to be seen if this improvement will be needed or not, depending on how popular the data sharding and rollup solution becomes. It's also important to mention that in the data sharding model, the current Ethereum chain becomes one of the shards, and this is the only shard that is able to handle transactions and smart contracts. The beacon chain is the next important concept to grasp to fully understand the ETH2 upgrade. But before that, if you made it this far and you enjoyed the video, hit the like button so this kind of content can reach a wider audience. The beacon chain is responsible for coordinating a proof-of-stake-based system by randomly assigning stakers to validate different shards. Randomness is important as it prevents stakers from colluding and taking over a shard. The beacon chain basically creates a new proof-of-stake network that runs in parallel to the current Ethereum chain. Launching it is one of the first things in the ETH2 roadmap. Initially, validators will be adding new blocks to the beacon chain, but they won't be validating the current Ethereum mainnet transactions. This will be possible once the current chain becomes one of the ETH2 shards. This brings us to the last piece of the whole ETH2 puzzle, docking. Docking is a process in which the current Ethereum chain becomes one of the shards in the ETH2 proof-of-stake system. This process will also mark the end of proof-of-work Ethereum that we know today and the full transition to the new proof-of-stake model. Docking will bring the ability to run smart contracts into the proof-of-stake system. On top of that, it will provide the full history and the current state of Ethereum, allowing a smooth transition for all of the ETH holders and users. Let's see how all the concepts that we just discussed fit into the ETH2 timeline. The whole development process is split into multiple phases. Phase U.
Yeah, so this part we have already seen what are the different phases and stuff. But yeah, if you want later as well, you can go and look at it. The next thing that we want to see is very quickly some small snippets of the merge party. So there is this very small thing that I want to sort of highlight as to what were people looking for during the merge, right? During the merge, people were looking at these
Yo.
data screens, right? This is the merge party hosted by Global. This is the
Do we have a
mainnet
screen
merging
share
party.
of some logs and stuff and some dashboards?
Sorry, I thought
Yeah,
this
to be
was
able to
something
share
I
screen.
had asked.
We thought you were going to express those to us verbally.
I am. I can do it all verbally.
I know, right?
So you can see that what people are looking at, they are, so for the first block that you see here, the merge, right, with the panda symbol, here people are looking to achieve a certain block difficulty. That's when the chain has moved from proof of work to proof of stake, right? So this is where you can see that the terminal total difficulty is this red one, and the chain is expected to slowly reach that difficulty level. And when it reaches that difficulty level, that's when it has switched. Then you see this counts per block. So they were expecting something like around 30 to 35 counts per block, right? When these many have so anything greater than 30, that's good. And then when these many counts started appearing, right, so there are something called attestations that these validators will do. So you can see like some drawings here, like some colors, it's very small, the font. There are transactions, proposer slashings, attester slashings. In orange you can see something called attestations. Attestations means validators are attesting that this block is produced, right? What are validators doing? They are also solving some sort of algorithmic puzzle, which is not as complex as proof of work, but they are producing new blocks. So in order to switch to proof of stake, they have to say that yes, I'm able to produce the new block on this new chain, right? So you can see these attestations, that's the count, right? How many validators are attesting per block. They had decided that this count, if it is something around like 30 plus, then it's a good number. They were saying like, okay, anything greater than that, it's great. Anything less than that, then it might be something dicey. So we'll have to see. So you can see the attestation numbers are also pretty good for this one. These are just connected peers in terms of how many peers are connected and how many actually running the nodes, etc. There is something with the epochs that there are two things with the epochs. One is called finalized and one is justified. So you can see there is a stair pattern sort of thing happening. These two colors actually, unfortunately, they chose very close colors. One is finalized, that is the block is finalized, and second is the block is justified. That is, it has been attested to that it is the right block that they want to produce, right? That's what attestation means. So here they can slowly see that ideally every finalized block should be a justified block, right? That means it's the right block that they're expecting. So this is what they are viewing under these epochs. Slots, I'm not 100% sure. There is something called hash rate that is hidden by this like terminal coming over, but I'm trying to, I think we'll be able to see that as well.
Okay. So I think we kind of got the gist. The proof of work chain exists. The beacon chain is watching and waiting for this terminal number, at which point the first block on the proof of work chain that it meets or exceeds this number, the validators say, okay, I'm ready. And they take over. And so at this point, they're all.
So you see, that's what is this difficulty. They will wait for a particular, the validators who are producing the blocks on the proof of stake will wait for this difficulty to hit a particular number, and then they will start rolling out the proof of stake
They're all
blocks.
watching, they're all waiting. That is the point at which the first proof of stake merged block will be built. So that's kind of, I'm going to go through kind of the sequence of stuff that we hope to see, the sequence of stuff that might be some red flags. We might start digging and that kind of stuff. So we want to see that first block, that the terminal total difficulty hit, that first proof of stake block. Then that proof of stake mechanism not only builds blocks, but validators send attestations. So these little messages that they say, this is what I see. This is what I see. This is the head of the chain. You know, this is my view of reality. And so right after we get that first block, we also start getting attestations. And so in each block, attestations from prior blocks and prior slots are included. So we hope to see over the course of the first epoch, which is 32 slots, which is about 6 minutes, we hope to see mini blocks. Optimally, we'll see 32. You know, if we see 30 or more, then we're golden. If we see a bit of a precipitous drop, something like 25 in that range, we're going to say, okay, something's looking a little bit weird. We're going to be digging in. But that's going to be one of our first indicators, is that first epoch, do we have mini blocks and do we have similar percentage of attestation? So, you know, if we're 90+% on the blocks and the attestations in that range, we're going to be very happy. There's also this thing, each block, the sync committee. This is also an indicator that similarly we want to see in that 90+% range. So after the merge block can happen anywhere inside of an epoch. So we want to see the finishing of that epoch and then the finishing of the next epoch. If we have over 2/3 of participation, we're going to call that justified, right? And so if we look at one of these panels, it says epoch, and we see how finalized happens and justified happens. That we see pretty much, you see an epoch is justified, then you see an epoch is finalized. So after that, like 6 to 9 minutes, we're going to see if we have 2/3 participation, we're going to see it justified. And then after the next epoch.
So they are saying if there is 2/3 validator participation, then this epoch is like justified, this particular block production.
We're going to see it finalized. So this process is going to take anywhere from 12 to 18 minutes, depending on where that terminal block lands. So let's see some of the other stuff in these panels that we might be looking for. So on some of the dashboards, we're going to see participation. We're going to see kind of these slots continue to increase. We really want to see these epochs increase. That consensus mechanism is going to switch from proof of work, proof of stake, ideally. And then we also watch logs. So nodes, the implementation of the software, they spit out what they're seeing. You know, they pretty much say like, hey, I got a new block. Hey, I this, that, you know, and it's not, it looks complicated, it looks a bit scary at first, but you know, a lot of this is just human language. It says ready for the merge and then stuff.
Yeah, so it says new block received, new block received. So I think these are the logs that they're just like monitoring what is happening.
Terminal difficulty, that kind of stuff. So we're watching logs. And one of the exciting things is when we see that first block, pretty much, I think all the clients have a nice ASCII Panda artwork displayed. So that'll be kind of our first exciting indication. We also watch block explorers. This is kind of a visual representation of the state of the logs of what's going on here. So this, you know, this beacon chain block explorer, this is an open source explorer. This is really cool. We get to see live as blocks come in through this sequence. We also get a little bit of indication when we're watching the epochs justify. So you get this nice visual representation as well.
So,
so
they are still trying to produce the first block production is still happening. So I'm going to show you just that moment when it does. When it says proof of stake activated. So
it is finally
like some Discord
now.
Okay, so
the new question is going to be, did it ever happen? Hey, I got pandas. POS activated.
Pandas. Come
so
on.
The terminal that you see is actually running, it's a client running a node, right? And they are expecting it to move to now.
Come on now. Let's go.
Thank you,
Pandas.
Connor.
Let's go.
So they're waiting for the
Panda.
panda. Oh,
Hey,
God.
right.
So we can see that proof of stake activated, and we can see that the terminal proof of work block hash is this. So basically, this entire log said they are like searching for, like they are waiting for this difficulty level to reach. On that difficulty level, once the difficulty level reaches, that will be the last proof of work block that was generated, terminal block. and then proof of stake is activated. So
Hey, and built on it.
Yay!
Building one
yeah, you
chain.
can see
So,
new RPC block received. That means the RPC signal has come that the proof of stake network is now like started
But we
functioning.
knew this would happen. We knew that we would get this far. There's nothing contentious yet. The next 13 minutes are the nail biting times. So now it gets fun.
Come on now. All right. I'm eating black licorice for ETH Finance, and I'm gonna drink some Lafroig scotch and a little bit of beet juice.
The merge is here. I've been waiting to say that for so long after saying the merge is coming for
Yeah.
years. It's here. Oh my God.
Come on.
I don't know.
Told we can't do sound effects, so I'm not. So I'm gonna just say, let's go.
Let me show you
Okay,
the
what's it?
beacon chain log, this one. So
Firmly
they say the next 13
So
minutes
once
are
we-
crucial because now is when validators are actually starting to produce the blocks, right? So the next 12, 13 minutes, we will see a lot of these blocks coming, that frame where they were saying it is moving from like proof of work to proof of stake, and then like I think
It's privacy.
Vitality.
We still have to make the thing actually secure for regular users and all of this stuff. And I think we all needs to work hard and do our part to make all of those other things happen as well. So I mean, I'm like to me the merge just like symbolizes probably the difference between sort of early stage Ethereum and the Ethereum we've always wanted early stage Ethereum to become. So let's go and build out all of the other parts of that ecosystem and turn Ethereum into being what we want it to be.
Awesome.
Just keep building.
It's worth
Yeah, so that's pretty much the advice, folks, for everyone. Just keep building because like this is again very, very early stages. We are just seeing things happening, and I think there is gonna be so much. Oh, there's also this. Okay. So there is some POAP collection that you can do, looks like, to be a part of this merge. If you can send $10 to stateful.eth, then you can claim your POAP, looks like. So yay. Okay, that's fun. And you can also get more info about what's happening right now with the beacon chain on the beaconchain.in. And yeah, that's that. Seems very simple, but has been a very historically amazing event that people have come together to, they pulled it off. So yay, kudos to all of us. And now I have this very small quiz, since I want to keep this like very short, like for 45 minutes. We are reaching the end of our merge party. I want to open up for like some, discussions, if anybody has any questions, or you just want to like have any thoughts that you want to share, feel free to do that. Share link. Okay, awesome. So what I'm going to do is I have a quiz that I prepared that I will share with all of you all, and I will share it with the community on Telegram. And for this, those who top 5 scorers of this quiz will get a $10 bounty. So we have a $50 bounty on this quiz. And we also encourage you folks to write articles about the merge. This is going to be one of the events, historically significant events in the tech space that will be talked about for a while. So it will be good to also create your own, a good branding for yourself. Just write some articles or maybe write some Twitter threads about what you understand from the merge. It'll be good to build your profile as well in a public forum. We will be happy to retweet, reshare, whatever support we can provide from our end to amplify your work. We are happy to do that. And yes, those who do the quiz, those who attended the call and will do the quiz, will be on the priority winnings. I know the bounty is not too much, but it's just a fun quiz on like Ethereum merge and just the Ethereum ecosystem. And you can use this $10 to probably claim that POAP, from the Ethereum community call. All right. Thanks everyone. Thank you for joining me. And I hope to see you all